this video, I'll go through circle theorems. It's a GCSE Higher Maths topic. Let's start from Circle Theorem 1. It says the triangle in a semicircle is always 90 degrees, or angle in a semicircle is always 90 degrees. Right, so if we got a semicircle, like I can see that this line is diameter, AB is the diameter of this circle. So if we use that as the longest side hypotenuse of the triangle, and if we make any other triangle, no matter where, it will always make a right angle triangle. Moving to the next circle theorem, it says the angle at center is twice the angle at circumference. Right, so from the same arc, if we draw one angle at center, and if we form another angle at circumference, angle at circumference will be half the size of the angle at center. Moving to circle theorem 3, it says angle from the same arc at circumference are always equal. So basically, if you can see that this is the arc, and from this arc, if you use two lines and draw an angle at circumference, no matter where, it will be the same size. If I draw an angle from there to there, this is x. Similarly, if I draw an angle, say, somewhere else, as long as the angle is drawn from the same arc, say from here and from this side of the arc, this will also be x. All of these angles, no matter how many angles I draw from the same arc at circumference, all of them will be exactly the same size. Right. Moving to the next circle theorem, it says radius and tangent always meet at 90 degrees, no matter where tangent is. So, for example, say if this is the tangent line, and if I draw the radius to that tangent point, it should make 90 degrees angle. And even if, say, the tangent is say there, still this will make 90 degrees. This is 90 degrees, this is 90 degrees. Okay, so this is a very simple and straightforward circle theorem. So radius and tangent always meet at 90 degrees. Moving to the next circle theorem, it says radius always bisects chord at 90 degrees. Right, the word bisects means cutting into half, and 90, like chord is a line which goes from one side of circumference to the other, but not to the center. So basically, as you can see, that this is the chord and this is radius. Okay, so if you draw radius, like radius always bisects. Bisects means cuts into half. So this line is exactly the same as this one here. Moving to the next circle theorem, it says in a cyclic quadrilateral, opposite angles add up to 180 degrees. Right? As the word cyclic suggests that this quadrilateral will be on the circle. Okay, and also the word quadrilateral means four-sided shape. So in a four-sided shape whose edges are on a circle, opposite angle or non-adjacent angles, like in this case here, A and C add up to 180 degrees, B and D add up to 180 degrees. I think it's a pretty straightforward circle theorem. Moving to the next circle theorem, it says tangents from a point to a circle are always equal. Right, first of all, I should tell you that from any single point, say from here, if I try to draw two lines, I can actually draw two tangents to the circle. So basically, from any single point which is outside of the circle, you can always draw two tangents. Okay, and then it said the circle theorem actually says that this tangent and this tangent, they will be of the same length. For example, from here, from the point B, two tangents to the circle at C, and A and C have been drawn, and their lengths are equal. So I would say even this one is pretty straightforward circle theorem. Moving to the next circle theorem, and this theorem says the angle between a chord and a tangent through one of the endpoints of the chord is equal to the angle in the alternate segment. Right, so this one I would say is a bit tricky circle theorem. I would say this is probably the trickiest of all of them. Right, why? Because at the moment, if I see, say, first of all, let me draw the line. Say if I draw the line, this is the line. If I draw the line, there is a line in the triangle. Okay, so this is the side next to which is x. So this angle x will not be equal to angle there or there, but the alternate one, the other one, this will be equal to this one. So basically, this is equal to that angle there. Right. Okay, I hope you understand. So this means if, like the side which is touching to the angle, which is next to the angle, that angle will be equal to the angle which is formed not next to that line, but the other one, but the alternate one. Right? Or if I use, say, if I think of this line here, and if I think, say, this angle here is y, okay, all of this angle here is y. So two angles formed here and here, these are not equal to y, but the alternate one, the other one, this one here will be equal to y. This is what this circle theorem says. Let's move to the next circle theorem. It says two radii and a chord of a circle make an isosceles triangle. The word radii is plural of radius, and an isosceles triangle is a triangle that have two equal sides. The third side is of different lengths. For example, in this one here, we can see that this is a chord, and this line and this line, these two lines are of equal length. What's the reason for these two lines being of equal length? Because both of these are radii of the circle.